In this video, we will further explore the scope of data engineering within the modern data ecosystem. In the simplest possible terms, the field of data engineering concerns itself with the mechanics for the flow and access of data. And its goal is to make quality data available for fact-finding and data-driven decision-making. As data has grown, so has the field of data engineering. From data being available in a single database that was relatively easier to manage, the world of data has grown to include wide-ranging sources, structures, and types of data. The field of data engineering concerns itself with the tasks of collecting source data, processing data, storing data, and making data available to users securely. Collecting source data, including extracting, integrating, and organizing data from disparate sources. To collect required data, you need to develop tools, workflows, and processes that help you acquire data from multiple sources, as well as design, build, and maintain scalable data architecture to store data. Data could be stored in databases, data warehouses, data lakes, or any other type of data repository. Processing data includes cleaning, transforming, and preparing data so that it is usable. For this, you need to implement and maintain distributed systems for large-scale processing of data. Design pipelines for extraction, transformation, and loading of data into data repositories. Design or implement solutions for validating and safeguarding quality, privacy, and security of data. Optimize tools, systems, and workflows for performance, reliability, and scalability, and ensure data meets all regulatory and compliance guidelines. Storing data for reliability and easy availability of data. For this, you need to architect or implement data stores for the storage of processed data. Ensure systems are scalable, keeping in mind the evolving nature of data and business needs. And ensure tools and systems are in place that take care of data privacy, security, compliance, monitoring, backup, and recovery. And finally, making data available to users securely. This includes the use of APIs, services, and programs that retrieve data on defined parameters for use by end users. Interfaces and dashboards that present data to users so they can derive insights from the data. And ensure the right measures and checks and balances are in place to keep data secure and provide rights-based access to users. It is important to mention that data engineering is a team sport. No one person is expected to have all the knowledge, skills, and specializations required for the wide-ranging tasks covered within the scope of data engineering. For example, to architect any data management system, be it for collecting source data or storing processed analysis-ready data, you need to have the skills of an architect. To ensure data stores are available and optimized for use, you need to have expertise in databases. Similarly, proficiency in database tools, programming languages, and distributed systems all come under data engineering, but they may require different skill sets. Also, not all teams and organizations need to set up an end-to-end data engineering practice. There are tools, applications, and solutions available in the market, both on-premise and cloud-based, that can be evaluated for individual needs. In this video, we learned how data engineering works to provide a robust and scalable structure to make quality data available for decision-making. More than any other data profession, data engineering is about the tools and technologies involved in data manipulation. But it is also about understanding the complexities of data and how it is ultimately leveraged for fact-finding and decision-making.